we've built the team in a way where we only like to hire people who like taking on larger, big challenges and solving them either by themselves or with a very small team. And that thing would remain. So I do think for anyone who finds that to be a compelling, exciting thing, um, like Foundation is probably the company they should come and work at. And we're
Yeah.
at this point like one of the three companies um, that have a robot that actually works. So Tesla's works, Figure's works, ours works.
Yes.
You need almost the same degrees of freedom that a human body has if you really want these robots to interact with the world the way humans do and be able to, over time, actually make um, different tasks a purely software problem, not really like a software and hardware challenge. I think the thing that is magical about the human hand, in my opinion, is at least like looking at it from a robotics perspective and moving back. Um, it has the right desired degrees of freedom and right like torque throughput. And the thing is, a lot of the use cases need a mix of both. Even if you take something as simple as opening a water bottle, so if you just want to take the cap off, you need more torque than you think you do. Like you,
Mhm.
and then also you need degrees of freedom that you think you need more degrees of freedom than you think you do. I am not of the opinion that you should try to emulate human muscles, only because if you did that, you're not going to be able to build a robot at mass volume and scale anytime soon. I think so. I think in next 5, 10 years, you will probably have billions of robots.
Okay. All right. It's not every day that you get to talk to the founder and CEO of one of the most exciting humanoid bot companies in Silicon Valley, especially a bot company that achieved 87% manufacturing efficiency in their first deployment. And now I believe it's about 90. I'm talking about Foundation Robotics and their humanoid bot named Phantom. Today I'm joined by Sankaet Pathak, founder and CEO of Foundation. Also with me are Scott Walter and Gustav Andersson. Scott is a mechanical and aerospace engineer and two-time founder of robotics companies. Gustav is a hand surgeon and associate professor of anatomy in northern Sweden. Welcome, gentlemen. Great to have you with me.
Yeah,
Same
thanks for
here.
having me.
All right, so where do we begin? This is super exciting. The last post I saw from you, Sanket, was you pushing around this poor little bot, giving it a good walloping. How's the bot doing? How's Phantom doing?
This is actually the most politest abuse the robot's gotten as of late. It's doing well. This was actually one of our first just off-the-cuff tests of moving from like a model-based controller for locomotion to an RL-based controller. We still have a long way to go. Like there are tons of things we want to improve, make the walk more natural, kind of increase the frequency at which the policy runs. But it's like even just right at the beginning, this is like way more robust in terms of standing than your model control policies usually are, with significantly less effort in terms of code. Obviously, a lot of effort in you still have to figure out all the reward functions and train a really good discriminator model as you want to make this more natural over time. But
Mhm.
yeah, this was like one of our first tests in Germany. And then since then, we've done a lot in San Francisco as well. And the robot's taken a lot of beatings. And every time we give him a beating, I give him a hug so that he remembers that it's all with love, tough love.
Yeah, that's good to know.
So what's the prime objective with having it bipedal and you running through these paces? Is it to make it
Yeah.
fast or more able to walk upstairs, or what's your approach there?
Yeah, I mean, so the basic philosophy that we've kind of settled on is you can either build a bunch of different form factors to do very efficient work for specific tasks. But if you just want to do generally almost everything that humans do, there's no substitute to it than a humanoid. So you just have to build a humanoid with very similar degrees of freedom as well. And there's no easy, like, sadly, the hard answer is the right answer. There's no like shortcut here. So, bipedal is again pretty much for the same reason. Like you go to these factories and there are aspects of these factories that are standardized, which is they've deployed industrial robots, and everything is done with like very tight tolerances and very strict assumptions. But then there's almost everything around it that is quite dynamic, which humans do today. And there is like if you really want all the factories and warehouses to get fully automated, you cannot expect them to change drastically. You cannot expect people to put in a lot of money into building a completely new infrastructure. Um, that just would not happen in enough time. So we think the best way to be able to do this is you deploy robots that work in these environments the way humans do. And sometimes that means taking small steps. Sometimes that means going through slightly rough, unstructured environment. You want to be able to do all of that, and legs enable you to be able to do that much more effectively. And historically, again, also legs are, and I've said this publicly, and some people dispute this, but I would actually argue legs from an electromechanical perspective are much easier than a full AMR. The biggest challenge on why people have done wheels over legs have been software, because you don't have to like write as much code and figuring out how to make how to balance itself and make it walk and do all these different things. But that thing's quickly changing with reinforcement learning. So I'd be very surprised if in next 12, 18 months, there's any humanoid company that is doing like a non-legged humanoid, because also humanoids are not the right form factor for long distance things, right? So if you want to do things miles away, you probably don't want a human looking thing holding a small box and riding to sunset. You want like honestly like in ATV or an AMR or something like that, carrying that and hauling it around. So I think legs are the right way to go for all of those reasons.
Yeah, I kind of agree. I think your quote was something like bipedalism will become a commodity. And I agree. I mean,
Yeah.
It took like 30 years before we get a decent walking robot. It was like a real big challenge. And
Yeah.
suddenly everyone can do it overnight. So it's become a commodity. It will become easier. I absolutely agree with you. There's short, medium, and haul things. We already have a solution for the long haul. It's called an AMR. So putting a humanoid on wheels is not the solution. It's just like we got that. And then that maybe it kind of works in that medium haul, flat kind of situation. But these short hauls where you're in a very confined space where you got to have mobility and stuff, it just makes the most sense. And again, the whole idea is drop in place. I don't want to have to reconfigure everything out there. First question that I have for you, Sankaet, is the name of the company. I assume it's an homage to the Asimov trilogy.
It is, and it's also because iRobot was already trademarked. So
Exactly. Exactly.
But it is definitely an homage to the Foundation series.
Yeah, absolutely.
Now, I see there's a lot of former Tesla employees in your team. What gives?
What gives? I think there are a lot of people. Tesla's become like a pretty big company, and I think a part of that ends up being really talented people are sometimes expected to do small subsystem type work. And when you join a startup, like you can just stretch your wings and do a lot of things. So a lot of the people that have moved from Tesla to Foundation, they've done it primarily for that reason, that they feel like they just have a larger scope and it's a smaller team, so you can get a lot of work done and learn a lot as you do it. I do think there's been a portion of the population who's also liked our actuator philosophy, and then also our model architecture philosophy on the AI side. So those things have been compelling for people. But primarily it's that, like, Tesla is a phenomenal company, but with any big company, you cannot stretch your wings as much as you can in a smaller
So Tesla is
companies.
phenomenal, but if you really want to spread your wings and fly high, come to Foundation.
Yeah.
I would like my pitch to engineers is like Foundation is Stark Industries in its infancy. So if you want to like almost if you want to see what a roadmap is, you should just read Marvel Comics, and you would know exactly what a roadmap is. And if you want to come and work on very ambitious things and kind of not take on small but very large sets of problems and challenges. Like, this is the company to be. Like, our R&D team is never going to be massive. Like, at the most it'll be 100 people. And the whole reason for that is we've built the team in a way where we only like to hire people who like taking on larger, big challenges and solving them either by themselves or with a very small team. And that thing would remain. So I do think for anyone who finds that to be a compelling, exciting thing, like Foundation is probably the company they should come and work at. And we're at this point like one of the 3 companies that have a robot that actually works. So Tesla's works, Figure's works, ours works.
I was just going to say, everything that you've been saying sounds a lot like the philosophy at Figure.
Yeah, except our Figure is also big.
Yeah.
So you work in a cave and build it from a box of scraps.
Yeah.
Was Stark also trademarked, or Stark Industries trademarked?
I think it is.
I think
there's a company in Germany or something like
Marvel
that already has it.
Yeah.
So Sankaet, I have. I'm just going to ask you a couple of questions about the overall philosophy, because this is what I'm kind of known for on X, is like breaking down and analyzing different ways. And one of the first big arguments, I mean, we've already kind of settled the wheels versus bipedal. Okay, that's off. The other is linear versus rotary.
Yeah.
Yes.
Like, what are my thoughts?
Well, yeah. I mean, I think you're using exclusively rotary drives. I don't think you have any linear. Are you considering linear? And what's your feeling of companies that might be hybrid, or do you just feel like it should just be rotary?
Yeah, I think that's a really good question. And I can answer the easy stuff first, and then I'll answer like the slightly more hairy stuff. I think it is better from a product and engineering perspective if you can focus on one actuator family and make sure you do a really good job with it versus arguably 2 or multiple. So I haven't been a big fan of these dual type of actuators where you have to build and design 2 different kinds of actuators and do them well. The second piece, I don't think linear actuators are by and large the right choice, is because a lot of the human movement is rotary movement. So like my elbow does that, so does my shoulder. And we don't really think, if you really want to be able to model out some of the dynamics and kinematics of these robots, similar to how humans need to be, linear actuators are going to be the right set of choice. Like, I think the control stack is a little bit more complicated than retargeting, like mocap data, for instance, to be able to do human to robot movement is going to be more complex. For all of those reasons, like we just don't think linear actuators are the right way to go. So it does have to be, I think the primary joint has to be rotary. And now since the primary joint has to be rotary, it's ideal if you only use rotary actuators and then make them really, really good versus trying to do different kinds of actuators at once.
Okay, so now that we're on that topic, a few years ago, no one even knew what the term actuator meant, and I had to explain to people it's just a fancy term for motors. Of course, it's a little bit more than that. You've got the control board, you get the motor itself, and then you have the reducer. Now, I've got kind of a funny story about the reducers that's going to lead in here. Is a couple of months ago, I was texting back and forth with a robotics friend, but I was riding my bike at the time, so I had to do it in my meta glasses. So that meant everything was basically speech to text. And I was saying, what do you think of cycloidals? And of course, Meta put it out as psycho dials. And I just kind of laughed because, of course, they're eccentric.
Yeah.
And
I
so
should just call them psychodials from now on.
Yeah, psycho, because that's basically kind of what they are. So that everyone in the audience knows there's different transmission systems, because motors like spinning. They like spinning really, really fast. The thing is, the output, we like to slow down a little bit, and we like to also up the torque. So you need to have a transmission system, and your choices are either like planetary, harmonic, or cycloidal. It seems to be most are going kind of harmonic. There's a few that are planetary, but cycloidals are kind of the new hot item out there. You're one of the first ones to kind of really go all in on that. And please explain what are the pros and cons that you see.
Yeah, for sure. I mean, so I think the first piece comes down to our philosophy, right? So our philosophy on actuator design has been, we don't think backlash is the most important metric to measure and care about anymore. Primarily because the use cases we're doing, even if there's some backlash, you can correct for that with vision. It's not really a big issue. What would become a big issue is if you have high wear and tear, if you have like high friction, which leads to high heat dissipation and impacts range. So things that really matter is these actuators should not have to be replaced on a very frequent basis. Second, they consume less energy. And as an outcome of that, either give you more torque on the other side or are just more energy efficient for the same performance. So we lean towards gearboxes that have very low friction. And even if that means it has some backlash, we're going to be okay with that. And for that purpose, you can use planetary or you can use cycloids. So you have a choice of doing both. We picked cycloids primarily because when I started Foundation, we weren't really intending to build actuators. We weren't really thinking of doing it. We were like, it'll be ideal if we just buy this stuff off the shelf. And we tested everything. We tested harmonics, we tested planetaries, we tested cycloids. There was this company called Boardwalk Robotics that had cycloid actuators, and we tested theirs. And theirs essentially had virtually zero backlash after you enable their motor controller, right? So it has some backlash if you just play with the gearbox, and virtually zero when you have the motor controller on. High peak torque, the highest peak torque for its size, the highest repeatable torque for its size, and then lowest back driving friction, right? So we looked at all those metrics and variables because we thought those were the most important ones. And it happened to be that what Boardwalk had built was significantly more impressive than a lot of Chinese cycloid and planetaries that we were testing and benchmarking against. So we decided to pick cycloids, and we're like, let's just run with this and improve, kind of like follow on things on top of that. Again, in the future, we might use planetary as well. Like, it's not something that we won't. I do generally like cycloid actuators. Like, mostly everything inside that gearbox is already manufactured in billions of units. So your ring pins in so many different applications, you use them. Your ball bearings, you pretty much have them in everything. The cycloid discs have tight tolerances, but not as tight as your string wave in your harmonic drive. So getting the machined is not as necessarily as difficult. And with the software controller that the team has built, we can get close to virtually zero backlash. So it ends up being like just as fine. So we stuck with cycloids. I do think for humanoids, my personal opinion is you should really prioritize a lower friction gearbox. And that could very well mean you use planetary if you have a good system with a planetary gear that works. We have good with cycloid, which works really well. So we just decided to use that.
Yeah, I'd have to agree that with the humanoids, there seems to be this obsession with precision, which is why they go with harmonics, which makes sense for the industrial robots.
Exactly.
But the thing is, you've got the punishing environment. So harmonics are not really good with a lot of vibration and shock. Yeah. They're also pretty expensive to mass produce. And the surprising thing with that strain wave, I mean, it's like really 70% is about the best. It's also a function of temperature. And it turns out the colder it is, the worse the efficiency. I mean, the efficiency can be like 30% when it's really cold, because the metal that's flexing, you want to warm it up so it's soft, and it'll never exceed that. And it's like, if we're going to have an external battery pack, I want to have that 90%. So I agree. It's like, come on, us meat bags, we have absolutely so much backlash and everything else. Yet the way we get precision is because we have cameras. And now that you have cameras, it makes a lot more sense. So it's good to actually hear it from someone to see what's going on. In theory, your cost of production should be really low because you don't need any complex grinding machines or anything like that. So that's great. So those are kind of my philosophical questions there, and I'll turn over to Gustav and Royden.
So I want to be the intermediary here, the dumb guy in the middle between the two, my brilliant co-hosts, Scott and Gustav. Because here on Over the Horizon, I try and bring these brilliant ideas from the likes of all of you gentlemen and share them with a wider audience that is not necessarily as technically clued in. but at the same time is extremely interested in all of these subjects. So before I toss it over to Gustav, I'm trying to get in a link, and that link is, when you think about building a humanoid bot like Trantham, and deploying it at factories where eventually you'll have them replace human workers for different tasks. How do you think about the problem of imitating the human body and evolution? And how are your design choices, whether it's actuators, etc., how are they defined or shaped by your learnings of the human body and the human musculoskeletal system?
I think again, that's a great question. Every time, so there have been instances in the last year and a half where I felt like I was more intelligent than evolution. And I was like, oh, that degree of freedom is unnecessary, not needed, remove. And every time we delete it, we pretty much learn the lesson that sadly the world, it's like a self-fulfilling prophecy. The world has been built around human degrees of freedom. Something as simple as you're like scooting down on the floor and picking up something, or you're trying to like get to the most corner downward rack of like a rack where you're trying to put something in. We use our hips and all these different things in all these different ways that we take it for granted where it comes down to when we're trying to build some of the stuff from scratch. So pretty much kind of like the realization I've arrived at is you need almost the same degrees of freedom that a human body has if you really want these robots to interact with the world the way humans do and be able to, over time, actually make different tasks a purely software problem, not really like the software and hardware challenge. So I think the degrees of freedom, I would concur with. It should be very similar to humans. Now, the actuator design, I am not of the opinion that you should try to emulate human muscles, only because if you did that, you're not going to be able to build a robot at mass volume and scale anytime soon. Eventually, does that happen? Maybe. Like I would argue humans have gone through, like, if you just take from the beginning of the universe, like billions of years of net evolution, and it's like a giant GPU cluster running. And like, if you really think your brain has more computation than that and can figure out the right solution, I'm very skeptical. So I do think in the future, probably you want to emulate human muscle movement, but the thermal packaging and maintenance and repair, and like we have the piece that robots don't have that we have is like this magical self-healing ability, which is we have all these hormones that over time repair our body and improve it. So you're dealing with like a very complicated system. So like the clone robotics type design, I'm not personally a big fan of, because primarily I think it's a good research project, but very hard to really take to production. So I kind of rely on things where the core physics doesn't have to be reinvented, and your rotary or linear actuators are pretty much that. Like you have known physics, known dynamics, you understand how to build them. Obviously, you have to work on reliability and make them better and better for robots. But I think that's a much more straightforward path to having these things be out in the wild in billions of numbers in like next couple of years, which I don't think the human muscle emulation actuators are actually going to get there in that time frame. I don't think.
Did I actually hear you say billions in the next couple of years?
I think so. I think in the next 5-10 years, you would probably have billions of robots.
Okay, not the next couple.
Fair. Probably not like next 2 years.
Okay.
I wish.
I think that's a fair point that you're making, because except in Dune, airplanes don't flap their wings. So
Exactly.
we take inspiration from biology, but we don't necessarily have to copy it. I'm also excited to hear that you removed degrees of freedom and then found out the hard way. So you really appreciate what's going on. So like one of the questions I always like asking is, if you had to remove a degree of freedom, which would it be? And if you could add one for free, which would it be? So let's start maybe with the arm. Which one would you take out?
Which one would I take out in the arm? I know which one I tried to take out. Which did
Okay,
not
tell
work.
what's that? There's no right or wrong answer.
So the wrist.
Yeah, exactly.
I tried to take out the wrist, and that is like a dumb idea.
Okay,
Does
now if you
not
could add
work
one to the
well.
arm,
Okay,
which
hang
one
on,
would
hang
you
on.
add?
Explain why. Hang on. Explain why it was a dumb idea.
Yeah, so I thought for the longest time I can just take my hand and move it to like do all kinds of weird things. And then it turns out, yeah, when you really have a small container and you need to be able to go in and get an object, what you're really moving is your wrist. You're not moving the rest of your arm. So there, again, lots of applications where if you took that degree of freedom out, you're not going to be able to do it like humans would, which it's fine even if it looks weird, but in some cases you just cannot do it. Right, so it's much harder to deal with those applications where you just like cannot do exactly what it is that you need to do well.
Okay.
So it ended up being we reintroduced the wrist back.
Okay. The reason I'm asking you that is because here on the channel, Gustav and Scott and I have talked so much about redundancy and how the human body adapts. Right, Gustav? So when you've told us about amputees and amputations, what happens? So
yeah, and fusing a wrist is usually a pretty good procedure when we make it stiff, but then that's primarily to treat pain, of course, and if you have a painful wrist, then it's as bad. But what we don't like to do is fuse both the wrists of an individual, because you lose a lot of personal hygiene options, if we put it that way. So, for instance, going to the toilet and drying yourself in the back, it's really hard. If you have two fused wrists, you would like to have one unfused. So in a way, perhaps when I state those things, it's when I'm coming at it from like a destroyed wrist point of view and not what is good. So yeah, I like the approach in general that you're saying, that you put it, as Scott mentioned, you take it away and then you realize you have to put it back. If you don't realize you had to put it back, you haven't removed enough. Isn't that from an engineering point of view? So
yeah.
And what
Okay,
you were
so now let's
following up
add.
on what you want to add.
Yeah, let's add.
Let's add.
Yes.
And explain the question to me a little bit more. I have no technical limitation or
Okay, no tech. Yeah, it's absolutely free. It doesn't cost you anything. You can just go ahead and add something. I mean, I don't know.
Another elbow, another.
add something that doesn't exist in a human body.
No,
Because
it
at
exists in
this
the human
point-
body, but it's like in order to emulate it, what's kind of missing from your arm that's not in the humans?
What is missing from the arm?
maybe
that's
another
not in
joint
humans?
or a
Maybe another.
Like a
degree of
shoulder,
freedom.
maybe problem.
Yep.
No, I think. Well, if I could do
Okay,
that,
I'm putting out
right?
the shrug emoji right now. Okay.
Yeah, I don't know how much I'd miss shrugging, but I do think I probably want this. So
Yeah.
the back movement in the hands, as much as I have the front movement, which right now these robots don't have. And
Yeah.
But what would you
Yeah.
achieve with that functionally?
That would be the scapula. That's like an 8th degree of freedom that allows you to lean more into your work. That's the main thing. But I have noticed that your shoulder is mounted, has a very strong, what I call dihedral angle, which means you already were thinking about the singularity, because you want to operate like this without limitations.
Exactly.
It's only when you get way up there that technically you're limited, but I mean, you can still get around it. It's just that that's a more rare position than this. So you've already thought about that problem in the shoulder.
Exactly. You're absolutely right. So what am I missing when I cannot do that? I know exactly what I'm missing. So we're going to do this. I don't know if you guys have seen in San Francisco now, there are these wrestling matches that happen. And right now, all of those wrestling matches are unitary robots. So we're doing a US versus China wrestling match in, I think, end of December, early January.
Really?
And
How cool is that?
that degree of freedom would make the punch much more stronger.
Without tear them apart, or
Yeah, exactly. Without having to use the without having to use the torso as much, right? So my waist, because right now to add more, the robot has to move like more.
I know what your bot's stage name is going to be.
Yeah.
Cycloidal.
You know what? Actually, now it's going to be that. It has been named
Yeah,
cycle.
there you go.
There you go.
So you were talking about durability, and that is the actuator you're choosing. I'm like Royd, and I have no technical knowledge, but would you say that yours is more durable than a linear or some other choice of actuator?
It can definitely survive more impact because like you have a rolling contact gearbox, right? So um, essentially you have the cycloid disc that sits on a bunch of ring pins in like pretty much the ring pins hold it, and then it's touching these ball bearings. It kind of like goes around, and you don't have like a string wave. You have very high contact movement. Here you don't. So if you hit the actuator, you kind of like beat it with impact, the likelihood that it stops performing well, or at least at the same calibration as it was before, is much, much lower.
The load is distributed all the way around the circumference, and it's not concentrated on just one or two teeth. So the problem with most gearing systems is that the whole load has to be carried by a couple of teeth, and the rest of them are literally free riding for like 330 degrees, and then they have a little bit where they have to do work. This way, you distribute it; it's way more balanced around there, which has huge advantages. And again, you think shock and impact and being able to deliver torque. There's tons and tons of advantages. But when you look at that thing, you're like, this can't work. Who came up with this idea? There's, I can look at a planetary gear system and say, oh, yeah, okay, that makes sense. But you look at this at first and you think that is absolutely crazy.
So power-wise, and I guess connected to torque, will it be a lot stronger? And I mean, we're talking about emulating human form, but with parts of what you're going for, I'm expecting you want it to be stronger than humans and faster.
So to Scott's point, right? Like what we've observed is most of these harmonic drive actuators are like 40-50% efficiency. What you're looking at with a cycloid disc is closer to like 95%. And pretty much that means for the same motor that you put in, like same size of motor that you're going to put in with a harmonic drive, you put in here, you get close to like double the performance than you would. So definitely higher torque throughput in these actuators for the same size than what its relative competition is.
Right. And when you're talking, I mean, I've heard people say that harmonics are like 70% efficient, but the reality is more like what you're saying, 40 or 50%. And when it's 40 or 50%, where does that power go?
Yeah, just heat.
Heats up. Yes, exactly. So it's not just draining your batteries faster, but it's also causing a heating problem, which means you have to have a cooling problem as well.
Yeah, which I guess in one way makes the robot more dangerous. I don't know, but definitely not like efficient.
That's all you do is rope-a-dope. When you go up, because you just rope-a-dope because they're notorious. They will overheat after a while. So just keep them running around the ring, and then he'll finally just overheat and boom, just go down.
So I'm not sure if this is true or false, but I read that the initial hunting routine for humans was that, which is we would just keep on running, and these animals
would get exhausted. Yeah, exactly. It was exactly. Yeah, that's how we learned to become long distance runners. We weren't the fastest.
The Vikings should know,
but we could definitely exhaust them.
Yeah, our forebears killed a lot of animals by hunting them over cliffs up here is the idea. Whereas I guess on the African plains, they kind of ran them down. Yeah, thanks a lot to the Achilles tendon design, and our calf muscles were very durable and saving energy. So heat and cold, I read that you want to build like a factory in the Arctic region or Arctis, or what was that about?
I think, so the thing that I am personally most excited and fascinated by is getting to a place where, so right now, most of the work these robots do, they do like individually, right? So if you have one robot doing this task called cladding, where where a part comes down a conveyor belt and it picks it up and puts a label on it, and QCs it and racks it, right? So overall work over there is what this robot is doing individually. That is the bigger yield and the bigger driver. Eventually, we want to get to tasks that require like a bunch of robots doing that task cohesively together. So for me, those big things are construction is like a big piece where you probably have to deploy like hundreds, if not thousands, of robots to construct on Moon, Mars. Antarctica is like a good proxy for that kind of remote environment. So Sahara Desert, you could do that there. Where you deploy a lot of robots, the forcing function is they all need to be able to synchronize and work together to build infrastructure. And people think I'm like, when I say this, I'm like joking, but no, really, like as soon as Foundation is profitable, one of the first things we want to do is build like a base on some remote area, which like Antarctica is like one example of it, but could be like middle of Sahara Desert or something as well. Primarily to be able to work on this thing that I call fleet coherence, which is having the whole fleet be coherent with with every single robot node in that fleet, so that you know what the other robot's doing at any given time, and you can do this like hive mind collective global maximum type workflow that you do when you train models. So the whole fleet coherence is like philosophical inspiration from GPU coherence, which is the cluster coherence that enables us to be able to train larger and larger models.
So you're not thinking of that island as going to be Ilsa Nubla, are you? Because nature will find a way, you know. We'll have that colony there, and the next thing you know.
That's true. I was thinking we'd call that city Terminus from the Foundation series.
Okay, that sounds good. Now you, I think you mentioned that the walking video was being done in Germany, and when I looked at it, I said, "Oh yeah, I recognize the window in there and the heating system." So where actually is the city that you're in?
So majority of our engineering team is in San Francisco. So I'm currently in the San Francisco facility. We recently
and you're literally in San Francisco, not there. You're literally downtown. Yeah.
Even our first production manufacturing cell is in San Francisco. It's next door. We're starting to build it out now. That's going to be capable of 1 robot a day type output later this year. Most of our AI team is based in Munich. So a lot of Patrick, who you just saw for a second, Patrick is based in Munich. He is the guy who did most of the key work on the deep variational base filters that we use. So him and his entire team that has worked with him for a long period of time joined Foundation, and we decided to open an office as a function of it. So sometimes I'm there, sometimes I'm in ESSA.
Okay, so these are based filters.
Deep variational Bayes filters, Bayes. So
Bayes
like
filters,
Bayesian,
right?
yeah.
Bayesian. Okay, I thought you were saying they were based.
No.
Well,
okay. I feel like every single name I should run by you first.
Is that a dad joke there, Scott?
Inherently better names.
Yeah,
he's the king of dad jokes.
Now, one other thing I noticed about the walking bot is that you have a different hip design, what I call the ARF hip. I don't know if you've seen my taxonomy of different hips, where I think Tesla is everyone went kind of ARF at first, and then they went to FAR. So is this like your first generation hip? Are you thinking about doing something a little bit different, or there's some advantages you're seeing? Because I did notice that your abduction is like really in close, where everyone else is kind of out a little bit further. You brought in a little bit closer, and also the rotary. So what makes it unique are so much the offsets, not the order of operations. Do you have any thoughts about that?
Mark 2 design's going to change.
Okay. So we leave it at that. The other thing I noticed is that there finally is a taxonomy for what to call these different ankle designs, these parallel kinetic ankle designs on the linear drives versus the rotary. So you're what they would call an RSU, which is Revolute Spherical Universal, I think.
Okay.
And are you thinking of kind of, I guess you're probably going to be considering keeping that same one and probably the Mark II, because that seems to be a pretty good design choice overall. Yeah.
Okay. You're absolutely right. The only thing that would change, which again is fine, I can say this, Mark 1 is flat-footed, and for Mark 2 we do want to add like the toe
box.
primarily because that yields it, like a lot of the RL stuff becomes easier in making it walk more natural.
Yeah. And squatting also. And if you may have seen the Unitree video where he was going down and trying to pick up the shirt off the floor, and you notice it was very difficult getting that deep knee bend because he was trying to stay on his heels the whole way. And if you can have that, you can actually rock a little bit forward. So yeah, I think deep knee bends and squats and stuff like that. And plus your walking gait will be way more natural. Absolutely.
Yeah. Okay. So Sankaet, if there was one thing that you wanted insight from Gustav on, and that would help you go from Mark, what is it now, 1.1 to Mark 2, what would that be? What would be the one insight that you could learn from the actual human musculoskeletal system without going into too much details, because I don't want you revealing state secrets now.
Yeah. I mean, I think I'd be curious to hear Gustav's opinion on. So I know I said that you don't really want to emulate biology to the T. I think the exception to that rule is hands. I do not see a path forward with the traditional linkage-based hand design with all the actuators in the palm to be able to get to a human level or subhuman or like above human performance, right? Like almost all performance is going to be below with the absence of it, because one, much harder to pack in all degrees of freedom. So all your abduction, abduction, individual movement of each joint, which almost all of that is really needed if you want to start doing things that humans do generally. And I don't see a path other than the hard path that in America only Tesla is walking, which is the tendon-driven hand. And now it seems like in China, some people are starting to pull some of that together as well. Yeah, I'd be curious to hear what you think about the hand designs.
Yes, so far, I agree. I think that you should not pack everything in here, but where I disagree with Tesla is you shouldn't pick it all down here either. I'd say you should have a hybrid approach, and perhaps something like the Woody hand that we looked a lot at last week, where they have the actuators in the fingers to be able to individually control the IP joints might be a way to go. I'm not sure how strong and durable that would be, but I mean, I agree with your basic philosophy that if you want to create a humanoid bot that's going to be able to do everything, you really need to solve the hand. And it might be that I'm too human anatomy based, that I would say, oh, you need tendons and you need small actuators in the hand. But I agree that if you put everything in the hand, it would be really tricky and it would be probably quite bulky. Unless you can kind of solve it the way the Woody hand seems to try to do. We've only seen demos, so we're not really sure what it can do. But
yeah, I mean, unless you guys disagree, I think they must have either invented new physics or that thing, it would not have the same torque throughput that you really need to get human level performance with those tiny motors that are sitting up here.
I think I know the trick. What they did is they changed the order of operation on abduction flexion. So normally you're seeing that there's like an abduction and then flexion that's going on. What they did is that they actually put the abduction up higher so that the tiny microdrive that's up there is doing the abduction, which is good because abduction doesn't need a whole lot of strength. So that means the flexion that's going on in the MCP joint is actually being done by a much larger actuator down here that gives 1 Newton meter. So up here, it's only 0.3 Newton meters. And for those, you only need that to keep whatever it is you're holding from falling off your fingers. But that last one's what you need kind of for that grip strength. So they can do 20 kilograms and they can do what would be the equivalent of, at least their fingertip strength is about 1.5 kilograms is about what they do. So that's what they're doing. It's, it's pretty good for something of that size, but you're right. If you want to get that really good clenching strength, that has to have a lot of power, something else. So I think that's the trick, as they said, we only really need the power there. We will kind of ignore it way out here for now. So I think that's their trick.
Yeah. And I'm not sure that's gonna take him the whole way. So I would ideally see some kind of combination where you, as we do, exert a large amount of force up here. Well, I can't, but others can. And then you have the fine motor control in your hand. And so I don't think you can get away if you want to have a good humanoid hand with to get
Yeah.
away from the ab and abduction. You need that.
Yeah, you
And you
cannot.
of course need the thumb to be able to oppose. And then the next steps would be to be able to kind of create this type of hand where you don't only have the grip, you need to be able to individually control your fingers as we can, and preferably both keep them straight while we flex the MP joint, as we call them. I think that and perhaps that's where you could kind of do a Wuji Tesla bot combo, where you have your long tendons to create the force from whatever actuator you have up here, but then put something small in there so that you're able to kind of extend than perhaps the flexion. So whenever you want to whatever that bot would do, but to be able to create this grip is good for grasping instruments or like balancing your scissors. I mean, you're not going to be able to have fine scissor control unless you have some fine finger dexterity, which I think it would be really hard to emulate that with all actuators up here. You probably can.
So you see, that's why he's called scissors, I'm called paper, and he's called rock. So just so you know that.
And the last thing that I'm not sure you need, but what I lack in most, and which Tesla are kind of emulating, is the movement of the fifth metacarpal and the fourth. So it's kind of forgotten quite often that we move this. But in a lot of our grips, we flex and rotate the fifth metacarpal like 30, 40 degrees forward. So it's quite a lot, actually. And then to reach over to the thumb to actually get tip to tip or pulp to pulp. Otherwise, they kind of go to the side when they're trying to oppose with the thumb. So I'm not sure. You could perhaps emulate that with abducting a lot and getting the finger to go there. But if you would do that, then you have everything that I would look for in a nice hand. And then, as we talked about before, can you kind of remove things? And of course, you can have a very well functioning hand by stiffening the distal joints, and stiffening the wrist is not the end of the world for most people. You can stiffen this joint and still have a very good functioning hand. So there are degrees of freedom that you could probably get away with, but maybe start with going for the basics, and then you can start stiffening them if you feel that, oh, this is not strong enough. Well, just stiffen this joint, and then perhaps you'll get a stronger pinch or grip. So
I think there's a good chance. I put a post out that Tesla might be moving to a hybrid, and the reason is because Elon either kind of let it slip out that the whole arm is 26 degrees of freedom, and it's like, well, wait a minute, is he talking about the arm or the forearm? If you're talking about the arm, they just dropped 5. And the only way it can do that is they decided the abduction is taking up way too many actuators. And so they're probably going to some sort of linkage mechanism that might be in there. That's one approach. Another approach that I think, if you want to go all tendon, is like the inspiration from the ankles is that basically you could do the abduction with flexion going on up. And if I pull on both those flexures the same way, I won't get any abduction. But if there's a little bit of differential, it'll go back and forth. And then you'll say, yeah, but what about if I somehow want to get like a pure flexion in there, or pure abduction, not get flexion? Well, that's why you have the extensor. So I think if you have flexures going to both sides and then an extensor right up the middle, you might have enough degrees of control to get everything you want for that movement, and then also really be able to stiffen up. And the other super advantage you get, 2 flexures means your grip strength is now suddenly doubled. So I don't know if that's what anyone is considering, but that's been my idea and what I'm going to be putting out there.
Yeah. Well, I think that's a really good idea.
So here's another thing we've spoken about often. Do you need to emulate the human hand if you're not restricted by anything? Because you've got so many hands in nature, right?
Yes, you have so many hands in nature, but none of those hands interact with the infrastructure we live in.
Correct. But in terms of certain characteristics like grip strength, perhaps.
I mean, it'd be good to have like the gorilla grip strength. I think that would be ideal. I think
will you get
the bigger thing?
Do you think you will be able to?
Yeah, I think you can get to gorilla grip strength. I think it's going to come at a sacrifice for dexterity, in the sense of you're just going to have to build much larger hands, which means they won't be able to do. You're just going to have meaty fingers, so you cannot do some of the stuff that we
or
can.
you have to get rid of the abduction, because when you have that strength, the abductors are having a hard time keeping in place, so you have to overpower them. So that's like you take away that degree of freedom just so you can go down there and have that strength. Yeah.
Yeah, I think the thing that is magical about the human hand, in my opinion, is at least like looking at it from a robotics perspective and moving back. Um, it has the right desired degrees of freedom and right like torque throughput. And the thing is, a lot of the use cases need a mix of both. Even if you take something as simple as opening a water bottle. So if you just want to take the cap off, you need more torque than you think you do. And then also you need degrees of freedom that you need more degrees of freedom than you think you do. Picking up a credit card from the table, it seems like you don't need a lot of torque, but you do up here to be able to pinch it just right and pull it down. Uh, so I think this human hand does sit, and again, a lot of this is also uh, self-fulfilling prophecy. If we had raccoon hands, the world would be designed very differently. And
Oh
if,
no, Guardians
but
of the
we have,
Galaxy.
but we happen to have
He said
these
Marvel.
hands.
Remember? Oh my God, we're heading to raccoons.
You know what?
It's
I
not
would
a
actually love the raccoon hands. Yeah. No, well, he finally realizes that he is a
yeah,
raccoon.
he did. Yeah, he did.
And he also says that it's like that my name is Rocky Raccoon or something.
Oh, yeah.
Yeah.
Phenomenal scene, by the way. Guardians of the Galaxy Volume 3. But anyway, so I think like it's just the hands the way they are. We've designed the whole world around it. It's same as other degrees of freedom. Um, Next, a really good example of this as well. A lot of people, including me, wanted to get away with a lot of degrees of freedom, but it seems like you need this, you need that. You kind of need this too. Like, so you need almost all of it if you want to be able to do like really good perception, and then based on that, like motion planning and things like that. Because humans do move a bit to be able to locate objects properly, and then just like do those tasks. Um, yeah, so I do think it's a self-fulfilling prophecy, but
So that's that's a beautiful segue to the supplementary question I wanted to ask you, which is about adaptability. So the human hands can adapt and evolve, right? Do you think? And you just gave the example of mountain climbers.
Mhm.
Do you think we'll ever reach a point where you'll have hands that can adapt?
This goes back to the same reason why I've been hell-bent on using one actuator family. Um, you don't I don't think in I don't think a company would be very successful if, and by the way, here I'm thinking like very successful as in like the next Apple, Google, Tesla type company. If you had a bunch of different end effectors for different things and with like different kinds of properties, because it's just inherently harder to build these things well. And if you have a catalog of 10 that you maintain versus one, we'd put all of our resources in one and make it really, really, really good. Now, to your point, I don't know. Like, I think this is a very interesting thing about robotics is some of these things we just don't have answers for, and it's going to be like over time you would probably figure out, because none of this is like documented really well. I intuitively think we can build one hand design that gets you the right balance in torque output and dexterity, and also strength and durability, right? So you would be able to do rock climbing, you would be able to do some of these basic things. You probably would not be able to do like without glove boxing, or even like without glove rock climbing, primarily because you don't have the self-healing nature in like a robot hand. Like our skin turns over like every few months. So we do have this like repair that happens in our hand. That, by the way, even if we took our hand and we kept on beating it to the pulp, like it's going to be very difficult for it to recover. So I think some of those things would be tough, but I do think I think there's one form factor in one design that gets you, by and large, what you're looking for across board. I think there's a path
At
to
least
building a
most of the
hand.
low-hanging fruit that you can cover in terms of functionality and profiles.
I would actually argue there's a path to building hands that would cover everything a human hand can do with more strength.
Yeah.
What about sensors? Where do you stand on sensors? Fingertip sensors, palm sensors. Do you need them? Can you do
Yeah,
without them?
I'll tell you where I stand on them, and then I'll tell you. Uh, I don't like tactile sensors, and the primary reason for that is they break pretty often, and you have a very highly unreliable sensor set that sits, and it's also not. It's very expensive to integrate.
Mhm.
So, the best scenario for us would be that you can just use torque feedback and vision, um, which again I would actually argue if you sedate a human hand and then you try to do it, to Gustav's prior point, the human body does adapt to some of this stuff and
Mm.
it can do it. But when I've made that bet 3 different times, I've lost and I've gone back to exactly what humans have. So maybe this is another that I would lose. I don't know, but we're trying. We're trying to do it without tactile.
Yeah, I mean there are other ways, but I think it's going to be tricky for certain tasks if you don't have some fine detail information coming from your fingertips. But I mean,
Yeah.
we don't, when we say that, oh, if we sedate the finger or whatever, give a block to the fingers, you don't feel it anymore. We also lose proprioception and all of these information. It's not just the skin sensors and the shear forces. It's also, we don't no longer know what happens in the joint, and your
Yeah.
bots will know what happens in the joint even if it doesn't feel the fingertips. So it might be
Exactly.
that we overemphasize the need for tactile receptors if you have really good control and information coming in from your actuators. And I always come back to
And your
this.
cameras.
Yeah,
Yeah.
your cameras that are
Yeah.
don't probably have a better. At least you could add more cameras so you can see what's going on behind your head. Whereas if we don't have any sensation and I'm not looking, it's really tricky. But they will see what they're doing.
You could build cameras into your wrist. The other
Yeah.
approach
Exactly.
that you may have seen what Tom Zhang has done
Tom
down
Zhang,
at Daxa Robotics is they have like over redundancy with the tendons. You know, part of it is because if one tendon breaks, it doesn't matter. We've got so many of them. The other thing is that each tendon is basically passing back a signal about where the forces are being applied. So they can actually use that as a proxy for touch. So they don't need a touch sensor in a way.
Yeah.
So I kind of agree that we may have more clever ways of doing it. So if it's like a nice to have thing, but we might be
Yeah.
overthinking the problem and saying that,
Yeah.
nature just came up with that because that's how it worked. And again, nature is able to constantly rebuild. So we don't
Yeah.
have to worry about the fact they're getting worn
Exactly.
down. But you're right. If that's the most fragile part, where the robot
Yeah.
is meeting the world, it's going to be wearing out. And these things have to be
Exactly.
reliable. And kind of getting this idea of useful work. I've talked about that before, that you need robustness, which is why you're deciding to come up with actuator design that's going to be robust. The cost has been on there. It has to actually be able to do a job, show up, and everything else. And a lot of it means it has to do whatever tasks that you want it to do at the same rate as a human with the same reliability. So you've been in some factories right now and you've got like an 87% efficiency. What I have to do is kind of define that. Usually the metric is something called OEE, like overall,
Equipment effectiveness.
overall effectiveness that you're having in there. And that just kind of measures everything that's going on. And so you're like in high 87s. They do the same thing. A good IE will go out there and see exactly what the employees are doing. Employees are not 100% either. Humans are going to have problems and stuff like that. They're going to drop things. They're going to be tired, whatever. So their efficiency is also not at 100%. And it seems like you are above that metric already. Is that correct?
Yeah. So the SLA for us that was established by our customers was 85% OEE.
Yep.
Which is also on slightly higher end of what humans are doing observable in those factories. But then to your point, Scott, like that is probably the best apple to apple comparison. And we think it's like such a straightforward metric to really start optimizing for and shooting for. We are now a little over 90%.
Mm-hmm.
And I see a path to like a highly autonomous system that does like 95% plus efficiency for these kinds of tasks because they're very repetitive. Like there's not a very complicated state machine sitting on top. It's the same thing. The part comes down the conveyor belt, you pick it up, you label it, you QC it, you rack it or discard it. And you do that like over and over and over again. And then to your point, sure, you could have like voltage drops and you can have some kind of like bad perception, which leads to bad gripping. So you're gonna have some droppage of parts and stuff. But I think you're getting to a place where a lot of that stuff is quite reliable in these use cases, and you can just like do them well. We still have some work cut out for us before we can get, because right now we have an operator sitting by for intervention, and the operator does have to intervene like few times every few hours or something like that. So there's still work to be done before you can just do this without an operator, and you could have one operator that is responsible for like 50 different cells.
He's called a foreman today, right?
Exactly.
Yeah. So he's already being paid. He's already being paid to do that. So
exactly.
I don't think you add that to the cost of the bot, just so long as it's the same ratio.
Exactly. Yeah. So I do think that we have some work cut out to get that better and better, but over 90% OEE now. So
wow.
That's okay. Yeah, that's pretty impressive. Yeah, I was going to ask you, where the error is going to be, and part of it is you're in a very unstructured environment, so you have like a lot of these edge cases, like say bad lighting, a part comes in at a really weird angle, all sorts of things like that are going to lead to that. But so long as you're beating the human, that's all that matters. And if your operational cost is going to be hourly, the same as what they're being paid, my assumption is like and what OEE means, like not for 5 minutes, it means like shift after shift after shift. So so that means you're able to come back and do it again and again and again. And so without that reliability and robustness, it's not even a fair metric. So at that point, when you're doing it, you just don't go out there, hey, did the cycle time, did it in 45 seconds, just like it's supposed to, no, 45 seconds for hours.
And some of this stuff ends up being like, it works in our favor, right? Because your OEE is accounting for cycle time, uptime, and reliability. So if you lose something on one, you can gain on that a little bit on the other. By the time that you kind of balance out these three variables. But to your point, that's exactly how humans work as well. So by definition, it's something that is, for the robots, actually achievable. And I think you will get above human performance on a lot of these like very, very repetitive tasks that do have some edge cases, but by and large, you're like the same thing again and again.
Yeah.
So speaking of learning, I'm really curious to get into the AI training. I see that you guys use Isaac Sim, NVIDIA's Isaac Sim, but just very quickly, because I think both you and Scott are running out of time. So take us through high-level understanding of your training pipeline from teleoperation to RL to sim to real, Isaac Sim, on the ground training. You said you've got an operator there, so I would imagine there's a certain amount of corrective action that is taking place where your bots are deployed.
Well, so the good thing about the operator is not teleoperating the robot. So all the operator is doing is something called nudges, right? So where the robot fails, it just nudges and corrects it, and then the robot starts it again and starts doing the task. So it's a much easier interface and system. I am personally not a big fan of teleoperated data collection, primarily because I think it is going to be a huge bottleneck for any kind of really good foundation model. So you have to figure out a way to be able to use a human skeletal tracking data, human demonstration data, human egocentric view, and a third person view, and integrate that and to be able to train policies and models, which starts looking awful lot like either you're doing some kind of diffusion model and then doing retargeting of the joints onto a robot, or you're doing some kind of like discriminator model along with your RL policy that gives it dynamic rewards based on whatever the optimization is that the discrimination network has been trained on identifying. Most cases, it is how human-like is the movement. I think that is I think that's most likely the right data architecture and model architecture. If you want to be able to build these models in large like kind of like data sets and like a foundation model eventually. The piece that I think on top of all of this that is really important that some companies have talked about, not a lot are doing, is like building this world model. So this this state-based model that holds uh, pretty much a lot of properties of your environment, the dynamics, kinematics, object relationships, like all these different things. Because what that really enables you to do is it enables you to build this like an encoded layer that is apart from this imitation learning layer that I would argue inherently understands what the task is and what needs to be done. And the example I use often is, how do you know that a model actually understands that a coffee pod goes into a coffee machine? And I think the only way to do that is if you can somehow encode the relationship of a coffee pod and coffee machine. And none of the RL stack does that. None of the VLAs really do it. Like a lot of it is imitation learning based on the VLA side. So you do need some kind of like state-based model that goes along with it. And you can, by the way, also use this state-based model to do a lot of like model-based reinforcement learning training. So you can also use that, to your point, as like a lossy compression type simulation environment for like a lot of autonomous RL training. So that's kind of like a general philosophy, and like that gives you like rough scaffoldings of what the architecture is that we're going for. Primarily, we think for you to be able to make these robots generally useful, and to Scott's point, like they account for all these small changes, right? The part comes down a little weird, it stops a little sooner. The cubbies are slightly different where they need to go, and you need to be able to perceptively zero shot through some of this stuff. And I think the way you do that is if you understand the part, its 6D pose, you understand the cubbies and like the holds and how those are and all these different permutations of them, the relationship between both of those things. Only then you can do these kinds of tasks much more like repeatably. Versus a lot of the VLA stuff doesn't have high repeatability today, because again, what it's really doing is it's trying to imitate whatever the training data had, right? So you can do like a large data collection effort, which I know like Figure's doing, and seems like a couple of Chinese companies are doing as well. And it's not that you should not do that. I think it makes sense to do it. I think you're still going to lose out on diversity in a big way without intervention data and or without like a world model. So I do think building some kind of world model is important.
Unless you have a lot of video of people spilling their coffee and missing it, and then they start to realize that.
Yeah, but then think of it this way, right? It took Tesla a little over a decade to be able to gather enough data to do FSD well. And I would argue FSD is like 5, 6, at the most 10 different skills combined. Manipulation is something else completely. Like it's much more complicated. And there's nothing like a Tesla analogous system deployed today that has been gathering this data for the last like decade plus.
Yeah, I agree with you. With the teleoperation is that first you have to faithfully really be able to track what that operator is doing, and you can kind of do it up at the course level, but no one can really do it on the hand. And again, that's the business end of the bot, and that's what you've really got to get down right. It's like these other gross movements, you can figure those out mostly. The physics is really happening down here, not somewhere else. And so you've got to grab it. And then the teleoperator never feels comfortable in their new skin. And so they're always hesitant. And they're always, so basically they're doing everything like a drunken sailor. And what you talk about is like imitation learning means the robot is learning to imitate us. Well, if we're going through the world like drunken sailors, it's going to be like a drunken sailor. So if it's trying to imitate what I'm doing, every now and then it does a task, it's going to do this. It's suddenly going to touch its nose, and it was not going to know why. And it's because why? It's because when Scott's doing stuff, he keeps on doing this to adjust his glasses. So like every little tick, every little thing that operator is doing, you somehow got to clean that up and make sure they're not subconsciously doing it. So, you know, and especially let's say the less intrusive, the more you go actually to first person video, the less encumbered they feel like. They're gonna be, you know, rolling up their shirt sleeves every now and then when the hoodie slides down. It's all gonna happen. So yeah, I think there has to be another approach. And again, grabbing what's going on in the fingers is just so difficult. Yeah, it's good to see that someone is like kind of thinking about the problem a little bit different, because I'm not sure that teleoperation is necessarily going to solve the problem like everyone thinks it is.
Yeah, and it's
It might
not
be good.
also going to be, you're not going to be able to collect the volume of data you need to collect for teleoperation. So
Yeah.
Okay, so I want to rush through a few more questions that I had that I find really, really fascinating and different about you guys at Foundation. First of all, is your timeline of deploying. So, correct me if I'm wrong, but you're still targeting about 40 to 50 bots deployed this year?
yeah.
Okay, and then what, about 10,000 next year and 20,000 in 2027?
Yeah. So by the way, when I say these numbers, I know they sound insane. So like, some people think that I might be saying these numbers to help fundraise, and the reality is I objectively sound like an insane person. So I don't think it helps with fundraise as much as people think it does. But I do think there's a non-zero chance of us being able to pull this off. So like, this is the most aggressive thing that I think we could be doing. And like, I don't really think you can hold the team to a standard that publicly you don't say. It's like, it's very hard, like, because people know exactly. It's like, I cannot say something else to the team internally and then say something else publicly. It just doesn't work. It automatically rebounces to the public goal. So then it comes down to, okay, what is the most aggressive schedule that we can come up with? So our first production cell that is getting built right now, we've built about 10 robots so far this year. Our first production cell that's getting built now, by end of October, would be capable of starting to build 1 robot a day, which means I can do between November and December, like a little around 60 robots, 70 robots. So with some margin of error, like 40 is kind of like makes sense. Plus we have 10 already kind of like built. So technically it's 30. So I could eat up October and November, and still I have a shot to be able to do that in December. So kind of like, that's where the first number comes from. The factory we're currently in the talks of building next year is going to be capable of doing about 30,000 robot output per year with 3 shifts.
And that's going to be in America? Or?
That's going to be in the US. So it's going to be able to build 30,000 robots for 3 shifts, which means about 10,000 robots per year, 1 shift. Which means I have to do one of 2 things. Either I should have built the factory before this year ended, or I can build the factory Q1, Q2, and then do 2 shifts, Q3, Q4, to get to 10,000. Or do Q1 and then take Q2, Q3, Q4 to ramp up with 1.5 type shift and get to 10,000. Then the next year I would expect us to be able to do 30,000, because we'd be able to do 3 shifts plus 1 more factory, so 10,000. So total 40,000. And then the following year, take the same math, I should be able to do 60,000 with 2 factories fully running, or 1 factory expanded to be able to do that, plus 10,000 for another, right? So the goal should be try to increase your capacity by 30,000 robots every year. And the execution on that is going to take about a year. So like, start with 1 shift and then scale that up to 3 shifts. So that's where those numbers are really coming from. Now, obviously, I walked you through like transparently the execution that needs to happen, and it's not easy. Like, all this stuff is very challenging.
Yeah. What's your limiting factor?
Well, currently the limiting factor is breaking ground on the factory.
Then probably actuators, because the number that you need.
How close are you to the final design?
Sorry, say that again.
How close are you to the final design?
We would really want to scale Mark II. We because with Mark II, we're making a lot of kind of like specific design for manufacturing type upgrades that we think are going to be just massively beneficial in making it very idiot proof to assemble and build, plus cheaper than what we have today. So Mark II in the most aggressive scenario, we have ready by end of this year. In slightly less aggressive scenario, sometime in Q1. And Mark II is the one that we would really want to scale.
Okay.
I don't think we're going to have supply chain problems for the 10, 20,000 numbers, but then obviously as you
which
start
was my
growing
next
them,
question because of geopolitics and the fact that you're one of the rare bot companies that is openly stated that you're interested in working with the Defense Department.
Yeah.
Or the Department of War, should I say.
Yeah, that is the new name.
Mm-hmm. So then
Yeah.
you have geopolitics come into your supply chains.
Yeah.
That then begs the question of
Yeah.
vertical integration and your dependencies thereof.
Yeah.
How do you approach this?
I think your two big concern areas as it stands today is your batteries and your magnets.
Mhm.
And I know for a fact that the US government's doing everything in their power to change that. I don't think you're going to start off there at the beginning, but I'm pretty optimistic that US would be capable of giving you a lot of the raw materials to be able to build some of these things here. As it stands for us, I think we have the strategies we need to be able to de-risk some of this without going into a lot of details about it. And I probably don't want to do that yet. That I feel good about, like we would not have a supply chain disruption on some of this stuff. Now, I do think, as kind of to your point, the whole geopolitical battle picks up and gets more aggressive. If it does, that might have impacts. And we're in conversations with like all the right people to make sure, like at least we get heard on the fact that, like for the entire robotics industry, the magnets and batteries are like two very hot topics that today China is the only answer.
Mm-hmm. Right.
That needs to change.
Yeah.
So,
Yeah. Now, just to put your number in perspective, so 10,000 sounds like a big number, but if you actually break it down to only 5 shifts a week, you need 48 per day. One shift, 8-hour shift, that's like 6 an hour, right? So that's not a huge, I mean, it's like every 10 minutes is one rolling off the line. Now that's fully assembled, which means every 10 minutes we got to multiply it by about 30 or something. Like we need to have 30 actuators. So that's kind of where the bottleneck is. But still, if you look in those numbers, that's very achievable. 10,000 seems like a lot, but when you stretch out over a year, it's just going to come down to what that potential bottleneck is. And the thing is, we know motors can be, and things like that can be produced pretty quickly because you can buy, there's small motors, drone motors from China for like $5 a piece. I mean, they're mass scaling. So it's possible to get that ramp. It may be a challenge to do that next year, but I agree. Once you get those scaling issues, and your only challenge, as far as I'm concerned, you can definitely build 10,000 bots next year. The question is, are you scaling the right bot? That's the only thing. I think that's your real bottleneck. If Mark II doesn't hit the mark, then you kind of delay a little bit. You don't want to build a crappy robot, I say. But if you have that, then I don't see any reason why you wouldn't be able to hit those numbers.
Yeah,
it's not insane. It's really not crazy. Batteries, forget it. I mean, there's plenty of batteries. I mean, come on, we're putting 30 times more in a car than we do in a robot. So that's very easy to scale.
For sure. And I completely agree with you. I think it does not make sense to manufacture a lot of robots that are not going to be great. So like you have to make sure your underlying design is something you want to scale with. Otherwise, you're just like, I think it'd be more fun to just put money, like just burn piles of money and then record a video and put it on YouTube than it would be to build 10,000 robots that don't get used. So, which is what Joker did in Dark Knight.
Yeah. No, but whenever thinking about the naming convention, so when you build your militarized bot, you have to name it Scott and Gustav or something like that.
Or paper and scissors.
You got to name it The Rock.
Paper and scissors, The Rock. Those are all good names.
Yeah.
How are you looking at the competition from China? I know you look at Figure and Tesla Optimus as your two main competitors in America.
Okay, so another thing that you might disagree with, but I don't think Chinese robots are that significantly ahead of US robots in terms of capability.
Hmm.
The piece that China has historically done a good job of than US is they design and manufacture at the same time, and they can do that at a much lower cost and ramp that up faster. So like they have more in numbers, and I think like all of that makes sense. Um, Look, these unitary bots still have tons of issues that need to be actually resolved before they can actually be used for anything serious. So, and again, US companies are dealing with the same thing. The only thing US companies are not doing is just saying, okay, we're going to manufacture and sell them in parallel as we're building this out. Um, China, it seems like the strategy China is going for is um, complete commoditization on technology front so that
Yeah.
manufacturing is your real moat. Um, which again, they're playing to their strengths, makes sense. I'm not necessarily like, I don't focus as much on the Chinese companies primarily because I don't think I have a good, less noisy gauge of what they're doing.
Mm.
I'm too, I'm about 2 to 3 degrees removed from it. Um, Obviously, as we start doing more defense work, I might not even be allowed to go there and visit some of these things. So I'm kind of removed from that. And second, I don't see how the Chinese robots enter the US market, given how political this whole thing has become around
Hmm.
the, the national security issue. Um, I do, however, show my team Chinese robot videos all the time, just as a way to be like, look, we have to be better than what we're seeing, and that means we just have to work harder than we are today. Um, and look, the responses I get back from the team are, well, but that's not really real. Here's the reason why, right? So like people obviously are kind of skeptical of some of the progress that China is making, but again, like I think China has such massive advantage on manufacturing as it stands today that all of this stuff is totally like irrelevant. I think China is going to be like a very, very like all the Chinese robot companies are going to be like tough ones to compete with. At least some of them, probably not all of them. Just like how BYD is for Tesla and in cars, like it's a very worthy opponent. And I am of the opinion over time that is going to force us to just get better both ways. So it's not just going to be like one way or the other. So like I really don't mind it. I don't think they're as far ahead as sometimes people think they are, but I think they're generally going to push everyone to get better faster. There is like if you talk to any robotics founder, one thing that I consistently hear is competition with China. So at least philosophically, we're all competing with the Chinese robot companies, which I think make us like we're not that complacent as we would be otherwise.
Yeah, but most of the other bot companies are focusing mostly on competition in the field of labor. For you, it's also defense.
Yeah, I think for defense, given the Chinese military parade, we cannot find ourselves in a scenario where you have disproportionate loss of life one way.
Yeah.
So I think,
Mm.
yeah, I think the answer is autonomy for warfare.
Yeah. Well, that's I would love to pick your brain and go down the rabbit hole on the entire defense aspect of it because it's a fascinating decision for
Yeah,
Foundation, and it is inevitable. But I would love to have a separate discussion with you about that or anyone from your team on the
yeah,
philosophies behind that decision and how you
I
see
can
that
talk.
panning out.
I can talk about that for hours. When I started
Wonderful.
Foundation,
So can
when I
I.
started Foundation, yeah, when I started Foundation at
Scott
the
is
beginning,
Scott is someone who hates to talk politics and geopolitics, by the way, right?
But when I can talk robots for
Yeah, you
hours,
can talk
don't worry.
robots. Maybe you should have a follow-up chat on that.
Yeah, yeah.
happy to,
Amongst other things.
happy to.
Amongst other things. Yeah, sorry, you were saying something.
When I started Foundation, I wanted to exclusively do defense. And then Mike, my co-founder, convinced me to be dual use. Otherwise, I was just like hell bent on only doing the defense angle, primarily because what I wanted to do was build these robots that can build cities on Moon and Mars, and I felt like the only place to learn those skills would be defense. So I was like, I just want to do defense. But now, obviously, we do dual use. But I can talk about defense for a long time.
Good. That's our next chat.
Great.
All right, Sankaet, thank you so much for your time. It has been such a pleasure. There are so many more things I want to talk to you about, but then our limitation is time. Thank you also, Scott and Gustav. Always great to hang around with paper and scissors. You complete me, shall I say, to be corny. Thank you, gentlemen. Till next time.
Yeah, thank you. Thank you so much,
Yep.
guys.
Bye now.